As a reminder, the teaching and learning support staff includes primary, junior, and intermediate consultants. And you have with you today myself, Michelle Lang, and Rhonda Hewer. We are supporting you with our intermediate just-in-time PD. The first thing we'd like to do is just do a timing check. We have scheduled these first just-in-time PD sessions to ideally be just in time, just ahead of when you are teaching with your students. So if you don't mind to take a second right now, where in the WRDSB long range plans are you and your students currently working? So I'm seeing answers in all three of our choices here. So 3 of you just finishing up with algebra, a couple of you just starting with spatial sense, and 1 finishing up with spatial sense. My sense is that it might be due to some of the transitions with the distance learning teachers, and that the face-to-face teachers who've been with the same students that whole time might actually be further ahead. So we're going to take this into consideration, noting that most of you are either finishing up with algebra or starting with spatial sense. This topic is going to be in time, and it's going to help us to determine when we're going to offer the next session, because we don't want to be too far ahead. So thank you for helping us with that timing check. On today's menu, we are going to start with some building fluency with number talks related to addition and subtraction of fractions. Then we will look at some models for adding and subtracting fractions, and we will see what's on your mind. There are several key concepts for fractions. And most of these key concepts arise throughout the late primary and junior grades, so that by grade 7 and 8, our students have already been exposed to these. That doesn't mean that they are fully confident with them, but they've at least been exposed. So the types of fractions, unit fractions, an understanding of the whole, equivalency, comparing and ordering. And then our focus today is on operations. And we just want to make sure that it's clear that we want to try to keep students within their grade as much as possible in terms of the curriculum. So even though we recognize you're going to have students who are lacking some of these key concepts, if we focus on operations, and today our focus is on adding and subtracting fractions, we can still build students' understanding of these other concepts, including unit fractions, the importance of the whole, equivalency, and some comparing and ordering, while we are doing the operations with fractions, so that our students are still working on grade level content, and we're going to try to fill in some of that background information as we go. The key concepts is actually a link, the word key concepts, and it links to the paying attention to fraction document. So if you want to look into that in a little more depth. And the merging and splitting is also a link, and that is to the clips that were written quite a while ago, but it helps give a visual for what that merging and splitting looks like to help students to see what equivalency means and not just to do it mechanically. So when we look at the grade 7 and 8 curriculum, and we think about addition and subtraction of fractions, there's quite a few similarities. You can see some differences where in grade 7, they are first coming across that lowest common multiple with the idea of being able to generate equivalent fractions and finding common denominators for addition and subtraction. And otherwise, they're very similar. The grade 8s are using different numbers, but in this topic, the focus is with positive fractions for our just in time today, looking at positive fractions, addition and subtraction. Okay, so fraction number talks. This is a chance for you to write a response again. How does thinking about money help you to add and subtract these fractions mentally? So just jot down in your Pear Deck thoughts you have about how thinking about money might help you to add and subtract these fractions. I like that we're seeing all of the different representations. So we're seeing a decimal representation. We're seeing the words 20 cents, 30 cents. We're seeing the words for the coins, 3 dimes plus 4 dimes. Fractions of a dollar. So the fact that you were able to make all of those connections is one of the reasons we want to be able to give these familiar contexts for students as well when it comes to our number talks. By grade 7 and 8, students often are feeling really disenchanted by fractions. They think that they're really hard, they don't understand them, they can't do fractions. When in fact, they do have a lot of intuitive understanding of fractions just from their experiences, and money is one of those places. So by offering familiar context to support students' understanding of fraction, addition, and subtraction, including that visual. So making students aware that I want you to think about money, and then we give them the number talk where we show one fraction at a time, the half plus a fourth, then 2/5 plus 3/10, and we continue showing one at a time, helping students make those connections with money. So when in the number talk, it's mostly mental. We don't want them to be doing long form equivalent fractions. We want them to be thinking and making sense of the fractions that they're dealing with. Similarly, an analog clock can be another familiar context. Even though we know students struggle to tell time with an analog clock, again, providing the visual and asking students to use the visual to think about the clock and how does that help them to add fractions. So using those familiar context with the visuals and going through one expression at a time is going to help students to develop hopefully that confidence that they do know something about fractions and some of that fluency with representing fractions in different ways, whether it's in terms of money with the whole as 100, whether it's in terms of a clock with the whole as 12 or 60, depending on the fractions they're dealing with. So visual, which we saw with the money and the clock, visual math improves math performance. This is a link to an article I'm not going to click right now, but it's on ucube.org, and it just underscores the importance of visual math to improve students' performance. And not only do we have some of the world's top mathematicians engaging with visual mathematics in their everyday lives, in their job, but new brain research also tells us that the visual can help with students learning numerical mathematics. And it's that connection that's most important. So you'll hear me reiterate that as we continue. So the key message is to make it visual. By having students explore mathematics visually, we create a bridge that supports them as they move from the concrete, which we see here, and visual, to the abstract, which is where we do want our students to be. We don't want them to be entering grade 9 and still be using visual models and concrete models to be doing this mathematics. But they need to use that as a place to anchor and make the conceptual understanding make sense for them. When we're thinking about representing in models, we want to make sure that we include the notation alongside the pictorial representations so that they're always thinking about that symbolic and the visual that it connects with. We want to stick with representations that have longevity. So the pizza model is one that students use often in primary. It doesn't have a lot of longevity across grades with content though. So we want to stick to some of the models like number lines, the use of rectangles, and volume. So some of that measurement connection, and the number lines, which also looks at measurement in that linear model. Those are the ones that students will be able to use with various number systems as they continue on in mathematics. And as I mentioned earlier, we want to build on that intuitive understanding that students already have, but don't think they have. So for example, we can say to students, if we take $1 and we add $1 and 1 cent, it doesn't equal 2 because our units are different, and helping them see that that's the same as taking a 1/2 and adding 1/3. We're adding 2 different units. It doesn't equal 2, and that we need to be thinking about the same units when we are adding or subtracting fractions. Again, this is a link. I'm not going to click on it. I know it's small-ish, but the purpose of this visual is to help you to see how mathematical models can be used as thinking tools. So we have the different models on the left, and then on the right, you can see that although going from real life to concrete to graphical to symbolic is increasing the level of abstraction, we don't students don't, and we don't necessarily want them to, just go in a linear direction. We want them to revisit. So when we think about whole numbers and kids in primary, they start with concrete and real life context, and they use these models, and then they might start to draw pictures before we get to the symbolic. It's the same thing with fractions, except when they're developing that fractional understanding in the junior grades mostly, sometimes they're not revisiting these different ways of thinking and representing fractions. And so we need to make sure that they have opportunities for all of those so that we can get them to that level of abstraction, that symbolic, and the fluency with the symbolic. So across the bottom, it reinforces those models that I talked about in the previous slide, where some of those measurement, volume and area, the number line as a length, and then the set model. And there's some sample problems there as well. Another piece of the using visuals and concrete is that when students use visuals and concrete, we can get an insight into their thinking that often isn't as clear if they're just using pencil and paper. Because if they're doing a calculation or a computation, we may not see what they did wrong or where they went wrong, whether it was just a simple calculation error or an error in understanding. If they're using concrete and pictorial representations, we're going to get a better idea of their understanding of the concepts. Okay, so let's get into some of the models. If I want to add 1/2 plus 2/5, one model I can think about is the array model. And because I'm adding halves and fifths, I'm going to create an array that is 2 by 5, and then I'm going to use a different color to represent each fraction. So you can see that I have half, 1 out of 2 rows, I've covered in red, and 2/5, 2 out of the 5 columns, I've covered in green. However, they're overlapping, and the overlapping counters make it challenging to see the answer. So instead, I move them, any of the overlapping, and now I can see my answer of 9/10. So the array model is actually quite simple, but it's powerful because students can see visually what they're adding and what they get as an answer. I am now going to invite you to practice using an array model. So you will see on the link of slides, a slide deck, that there's a set of 3, and I've alternated purple and orange title slides. So if I can get you to choose either an orange or a purple title slide and add your name to it, and then practice using an array model. Oops, wrong one. Just a reminder too that using the shared Google slide allows students the opportunity to see, like they would with a non-permanent vertical surface within the room. So if they're struggling a bit, they can go ahead and look at other slides to see what other students are doing to help them out. No, I think it does that. Okay, folks, I interrupt your thinking because I want to have us talk about some of the things that different people did. So I'm going to get you to go to um, slide 17. So I'm going to have us all go to slide 17. And I'm going to ask Martine to explain her thinking. So Martine, can you tell us what you did on your slide 17?
Oh, sure. Might be a little bit loud once in a while. I'm at home.
That's okay.
I made an array. It was a 3x4. So I had 12 altogether. So I could easily put 3/4 in red. And then I started to add 1/3 of that And so I started to put the green, I guess they're dots, green circles. But I realized that once I put them in with the red dots, I couldn't, for some reason, I couldn't erase them. So then I undid what I did, and I knew that I needed to do 4 green dots. So I put 3 of the 4 here, and then the last one was outside. So it was 1 whole and 1/12.
Okay, so let me go back for a moment. How did you know you were going to need 4 of the green dots or counters?
Because 1/3 of 12, which the array is of 12, 1/3 of 12 is 4.
So visually, what does that look like?
It is one, if I'm looking at it horizontally, it's 1 whole row.
Okay, so you took that 1 whole row, and instead of putting it across the row, you've put it down the column, and you did that 1 extra. How did you know that 1 extra was 1/12?
Because one of the rectangles is 1/12 of the whole array.
Okay, great. Thank you. And so I noticed that some of you built a second hole, which helps to see that, but Martine's solution is very clear and didn't require that extra work. So well done, Martine. And now I'm going to ask you to jump to slide 21. And Kate, what I'm noticing is that in the slide you did for adding 3/4 plus 1/3, you have both red and green, but in this slide, you don't have both red and green. So can you tell me about that? Kate, are you there? Is Kate unmuted? Oh, she didn't do slide 21? Okay. Well, I'm going to jump. Okay, I'm going to have you jump to slide 12 then. So I'll have everybody jump to slide 12 instead. And Amanda, you are using red and green. So can you tell us about that?
Yes. Okay. So I did 8 boxes because I knew that there was 8 pieces in the whole, and I covered. Oh, I need to go to my slide as well. Sorry. So then I covered 5 of the counters, or sorry, I covered 5 of the boxes, and then I knew that 2/8 I did as green. And then I removed the ones where there were both a red and a green counter in them. And then I knew the answer was 3/8.
Tell me a little bit more about removing both. Why did you do that?
Because then I'm taking away. So I'm like I'm taking away the ones where there are 2.
So the green represents the fraction you want to take away. The red represents the fraction from which you're removing. And so by taking both of those away in the rectangles, you're going to be representing the answer.
Yes.
Does that make sense, what I said? Is that what you mean?
Yes.
Okay. Thank you very much. Okay. I'm going to head back to the main Pear Deck then and continue with this question. How are you feeling about that whole idea of adding, subtracting fractions using an array model? Sorry, I can't get to show responses unless I do that. So most of you are understanding. For those of you that are still struggling a little bit, the first thing I will recommend is that you revisit this slide deck when we share it And if you're still struggling a little bit, please reach out to Rhonda or myself, because it would really just take a few minutes for us to sit down with you and go through it virtually again and support you in those areas that you're still a little unsure. So first step is to try going through it again, like practice some more with the slide deck once we share it tomorrow, and then reach out if you're still need support with that. We're going to look at a second model, the double number line model. And again, we want to use a familiar context. So here's my context. And the whole point of using a double number line is to help students get to that common whole. So consider a bike ride in which I complete 1/4 of the ride before my first break and 1/5 of the ride before lunch, 1/5 more. What fraction of the ride have I completed by lunch? Now, when we think about that thought bubble, a reasonable distance, look at the bike I'm riding. So what would be a reasonable distance for a bike ride considering the two fractions given? And I'm just going to ask somebody to either type it in the chat and then Rhonda can tell me, or unmute and tell me. What would be a reasonable distance if I'm thinking about fourths and fifths?
Steve says 20 kilometers, 20.
Okay. I anticipated reasonably well. So if my common whole is 20 kilometers, and hopefully the bike helped you to figure out that it was 20 and not something else, I know that before my first break, I went 1/4 of the way. And after my first break before lunch, I went another 1/5. So first of all, I want to note that the context really lends itself to the number line. If I had been talking about cookies or sharing a cake, it wouldn't lend itself to a number line. So the whole point here was to give a context that lends itself to that double number line. So now if I know the whole distance is 20, I just have to think about, okay, well, what is 1/4 of the distance then? And that goes on the bottom of my number line. So I know 1/4 of the distance is 5 kilometers. Then I'm going to go another 4 kilometers because that's 1/5 of the distance. So that by lunch, I have traveled 9 kilometers, which is 9/20th of the total ride. So the whole idea with the double number line is that we've got the fractions on one side and the common whole, the whole numbers on the other side of the number line, or bottom of the number line. So what if students suggested a 100 kilometer ride? Same thing, I could still represent it, show my 1/4, which is now 25 kilometers. Then I'm going to go another 1/5, which is 20, to get to my 45 hundredths of the ride before lunch. And this is a good opportunity to help students to see, like, are these equal? Are they the same? How do we know? And have that conversation, because you might have students suggest the 100 kilometer ride. Maybe not on the bike that I showed. That would be a little tricky to do that in a day, I think, but I'm not that great of a cyclist. Okay, so that's how the double number line works. Once again, I'm going to give you a chance to practice. So this is a separate slide deck, same idea, a set of 3 slides, choose a set, add your name. The other thing I want you to be thinking about here is what potential issues might your student encounter. So as you're trying to solve on the 2 slides, what potential issues might your students encounter? Okay, once again, folks, I'm going to interrupt your thinking. I know that some of you are still working, and one of the challenges is that the math thinking might take less time than the maneuvering with all of the objects on the slide. I'm going to ask us all to join slide 14. And I'm glad that SJ is only partially finished, mostly finished, but partially completed the most recent thinking. So on slide 14, SJ, can I have you talk about your thinking? Actually, I want to, first of all, I want to note that when I first was looking at SJ's slide, I saw the 2/3 arrow, the 1/5 arrow. I appreciate that they're labeled. And then I saw the number 100 at the right end of the number line. SJ, can you talk about that first?
First I did 100. Sorry, can you hear me?
Yes.
Yeah, okay. So at first I did 100 and I went, wait a minute, 100 doesn't work because 2/3 doesn't divide evenly very well into it. So I picked a number that was much more friendly than the number. And so I picked 60 because I knew that both 5 and 3 divided into 60. And then you can see that my arrows aren't, my number line isn't real great, but it is an open number line. And that was why I picked 60.
Okay, so then can you tell me a little bit more about all these other numbers that are below your number line?
Well, I have 20 as a third and 40 as 2/3, and then 60 would be 3/3. And then the 12 is a fifth, the 24 is a fifth, the 36 is a fifth. And then I ran out of time, and I find that the kids can do it much faster than I can.
Oh, you mean the manipulating of the things on the slide?
Yeah.
Okay. So how did you get to a 12th or 12? Sorry, how did you get to 12?
I just took 60 and divided it by 5.
Okay, and so you are hoping to be able to show all of those partitions of the number line into those fifths.
That's what I was trying to do. Yep.
Okay, thank you. Thank you for sharing that thinking. So students are going to do the same, and one of the best parts about these shared Google slide decks is that, like I was able to see as Sheila was working, I could see her thinking. I could see that she changed it from 100 to 60. I could see her then going and making her marks for thirds of the line to figure out what was 1/3, what was 2/3. So this gives you a lot of opportunities to assess students' thinking and to see where their mistakes might be, and to give you a place to prompt to ask those questions either individually to that student, either on the slide in a comment, or when you're coming back together as a whole group. And then the other slide that I want to have a quick look at is slide 12. So if we can go to slide 12. And I like slide 12 because I like Rennie's context. So Rennie, can you tell us about your thinking here, please?
Hi, I wanted to make it walking, and then I realized 8 kilometers of walking was maybe a bit too much to go to the store. So then I was like, okay, well, I'll make it meters because that seems like I would walk 800 meters, sure. So I said I was walking to the store, and that was 800 meters away. So, and then I dropped my wallet, so I had to go back an eighth of the way. So where am I now? So then I just went 3/4 of 800 was 600. So I managed to put that in there. And then I had to go back an eighth of the way. And I was like, ooh, 1/8 is so easy. That's only 100 meters I have to take off. So I was super excited about that. So I'm 500 meters from home.
Great. So what I like too about Rennie's representation is that you can see home, you can see the store. So the context is visible there. And as she mentioned, 8 kilometers didn't really make sense for her context. So she was able to just adjust the units. So again, I'm getting a lot of information about Rennie's thinking, even in terms of her thinking of measurement, not just of her fractional sense. Okay, I'm going to invite you back to the Pear Deck to once again let me know, how are you feeling about adding and subtracting fractions using a double number line as a thinking tool? This one? Oh, thank you, thank you, thank you. Okay, that's better. That looks really pretty. So we can see that most of you are feeling pretty good about adding and subtracting fractions using a double number line. And that's the first step. If you're feeling fairly comfortable and confident, then it's going to be something that you can support your students in doing as well. One of the other questions I wanted you to consider as you were using the double number line was, what do you anticipate being those trouble areas for your students with that particular representation? So I'm going to invite you to unmic because I can't really see in the chat. So if anybody has something to add, what do you think, what were some of the things you thought students might encounter as challenges?
I think that some of my kids, especially my kids who are learning, I have a couple of LD kids and some kids on IEPs, I think they're going to get confused with the different arrows and the openness of the number line.
Right, and that can be a challenge across the grades with that open number line. So in that case, you might start with some number lines that aren't open and give them some of those benchmark fractions to help students with that kind of thinking. But yes, that is going to be something you can anticipate some students will have a challenge with. Anything else?
Here's one. Kate says, sorry, I can't believe. Please get one on the double number line. One number line. Just because we are
Actually, rather than the fractions with different denominators, it is that we're representing two different things. The double part comes from, and I'm just going to back up on my slide deck here. The double part comes from the fact that you're representing both fractions and whole numbers on the same number line so that students can make sense of it. So they see the fractions on the top, and it doesn't matter if they're on top, they could be on the bottom, but one of the representations, one of the, yes, so fractions on top in this case, and then the whole number, which helps us get to that common whole on the bottom. That's why it's called a double number line, because you can use double number lines for percents and whole numbers, where you have the whole numbers if you're trying to find percent of a number, and the percents are on top. So 0 to 100, and then 0 to say 60 is the number you're trying to find a percentage of. So the double number line is called that because you have one representation of number on top and a different representation on the bottom.
okay.
Any other challenges that you anticipate your students might have or questions you have at this point? So there are quite a few areas with fractions in general that students might struggle with. And we've shared these before in the just-in-time slide decks. This information comes from Leaps and Bounds and from the experience of the writers, the authors, having worked with a lot of students with fractions. So there's all of these areas that students might struggle with. And this ties into those key concepts that we saw at the beginning of the slide deck, that there will be some concepts that are before grade 7, 8 that students struggle with, but through a focus on adding and subtracting fractions, you're going to be able to address some of those through the visual models. They're going to get a sense of size of fraction, and hopefully they're going to understand through those models that they're not just going to try to add straight across, although you're still, that's a common thing that students do. So I'm not going to read through all of these. This is something you can revisit as you begin your unit, your topic of addition and subtraction of fractions, just so you can anticipate some of the things that students might struggle with and have something ready in your back pocket to support them. So one of the other things that we want to provide that some people have found helpful is a sample week at a glance. So this again is a link. I'm just going to open it here. What the sample week at a glance does, and it's just a sample, it is not meant to be the exemplar, it is just a sample. It starts by saying, okay, if this is what I want to do is add and subtract fractions, and this one is applicable to both grades 7 and 8 at this point, I want to first see where students are at. So on that day 1, it's a diagnostic task. And we've provided some of those resources for you to be able to do that. Then on day 2, now I'm getting into, okay, what are some of these visual models? And Steve Wyborny has a fraction splat series that, again, I think students find less threatening. So basically the way this works is that there's a total number of 4. It shows you 4 holes, but some of them are covered up by the splat. So what must be hidden? And they're just a math talk, a number talk that you can have with your students at the beginning. So there's a couple of those. And then I've pulled lessons from Math Up. So even those of you that don't have Math Up, you can use these because I've pulled all the pieces that you need to use the Math Up lesson. You'll notice that that can take a couple of days. So day 2 and day 3 are the same goal, the same Math Up lesson. We've got the Minds on Action Consolidate, and then we've got the lesson summary so we can review what it was that we learned yesterday. There's a prompting question, and then the Your Turn questions for students to practice. And then I've done the same thing with the next Math Up lesson that focuses on subtraction. And making that connection between addition and subtraction is important. So then the following week, I might then use some other models. So focusing on finding multiples and finding lowest common multiple, I might use the number line to get me going on that, to look at those common wholes. And there's some Math Up lessons I've referenced there, as well as the grade 7 long range plans. So this is just something that helps you to see what might it look like a week at a glance, and it's something that can help you get started. It's always going to depend on where your students are and what their areas of need are, but it's a place for you to start is what it's intended to be. And it does make sure that across the week we are addressing all of the components of the comprehensive approach to math. So the building fluency, not every day. The 3-part problem-solving lessons, again, not every day, and purposeful practice. But over the course of the week, we've made sure to address all of those. The long-range plans as well are there, and the purpose is for you to use them. They, again, have all components of the comprehensive math, a slide deck for each to give you different possibilities for some of those problems. I just wanted to point out here that there have been a few more days allocated to grade 7 because you're developing that understanding. In grade 8, you might need a few of those extra days this year just because last year was cut short and there might be some more gaps. But in general, the grade 8s might have a bit better sense of the fractions from their experience in grade 7. So they may not need as long. And that just gives you some flexibility because you're just coming out of topic 3, which is geometry and spatial sense. And for the grade 8s, that might take a little bit longer with some of that Pythagorean relationship and the Pythagorean theorem. The other thing I wanted to point out for both teachers of grade 7 and teachers of grade 8 is that link to the fraction diagnostic thinking task. Because it's adding and subtracting, the grade 7 diagnostic thinking task is going to be relevant now, and then that grade 8 one will be relevant later on when we're doing multiplication and division of fractions. So the grade 7 one focuses on adding and subtracting and does a little bit of diagnostic for those 2 operations. Okay, so hopefully you found that valuable. As I mentioned earlier, we will be making sure to share the slide deck and share the recorded session so that you can revisit if you want to revisit those models and the practice slide decks. And for those people who aren't here today, they will be able to see all of your thinking, which is helpful for them as they think about their students. So the next topic will be intermediate data literacy. We intentionally left the when blank because we wanted to see on that first slide where you are. And so Rhonda and I will look at when would be an appropriate time based on where the majority of you are now, so that we can still be just in time, just ahead of when you're going to be planning for that data literacy. And so we will share that closer to the date. And then, Rhonda, did we ever get any Slido questions? Okay, so no Slido questions. Is there anything else that is on your mind now? I am actually going to stop sharing my screen so I can look at the people. Any questions, you can either unmute or jump in the chat. You can drop it in the chat. And of course, if there are no questions, we thank you very much for your time at the end of a busy day. And we look forward to seeing you at the next one when it is scheduled. So thank you very much for your time. And feel free to reach out if you come up with a question along the way.